Alright, here is my midterm exam board. Have it set up with the first three toggle switches being A, second three toggle switches being input B, last four switches are being the opcode, but we are only using three of those. The last switch will always be set to 0. This little board here is to let me take 8-bit inputs in my code and turn them into 3-bit inputs in my implementation, and it's just taking those last 5 bits and setting them to 0 by directly plugging them into grounds. And here is my legend of how the thing should work. As you can see, all zeros is multiply, so we are going to multiply. So right now we have 1 times 0, nothing is on. 1 times 1, I get 1. And as you can see, 1 times any combination of A just gives what my combination of A is. Setting B to 2. 2 times 1 lights up 2. 2 times 3 gives us 6. 2 times 4 gives us 8. Let's go. 4. 4 times 4 gives us 16. There we go. 4 times 5 gives us 20, and so on and so forth. You can see all the multiplication. Now we will move on to division, setting opcode to 1. Right now we are trying to divide by 0, so everything is lit up. Let's set A to 4, and then we can do some division. So 4 divided by 1 equals 4. 4 divided by 2 equals 2. 4 divided by 4 equals 1. Let's do 6. 6 divided by 1 equals 6. 6 divided by 2 is 3. 6 divided by 4 is 1, and we do not get a remainder with this setup, so that is as far as that will go. Let's check out some subtraction. So we are now in opcode 0010, which is subtract. And this is going to be subtracting B from A. So first let's set our A. Again, we'll set it to 4. Subtract 1 gives us 3. Subtract 2 gives us 2. Subtract 3 gives us 1. Subtract 4 gives us 0. And if we go more than that, we go out of range, and you see all the lights come on. Let's check out our AND setup now. So we have opcode of 0011. So this will only have a light come on if A and B are both set. So right now, the first bit of A is set to 1. Nothing comes on, but when they're both on, we get that. Turn off A and it goes out. Now we will set all 3 bits of A to high. Now we go. Putting the B bits on one at a time, you see they light up in the AND configuration. And just to show there's no shenanigans, I will turn the A's off one by one, and they will go out. Next up, we have our OR, which is opcode 100. So now either A or B will turn them on. So as you can see, A turns everything on. B turns them all on, and if they are both on, everything stays on. Turning everything off now. We'll check out our not A next, which is opcode 101. So the reason all these lights are on is because I have A's zeroed out. Let me set all of the A's to 1 except for our 3 on the switches, so they stay off. Just makes it easier to see. And I did that just by switching this little wire from power to ground. So now bits 4 through 7, I have a 1 input, so they're turned off because it's a NOT gate. Turn 1 on, the light 1 goes off. Same with bit 2, bit 3, all together. And our NOT gate is working. Now I'm going to set our extra bits back to being 0, and as you see, when everything's in 0, all 8 bits come on. Next up, we have an XOR gate, which is 0, 1, 1 on my opcode. This one being 0, 1, 1. So we have the XOR. So this will come on when only one of the bits for A and B is on that corresponds to that number. So we turn A1 on, and you see light 1 comes on. But we turn B1 on, you see it goes off. Same goes for A2. B2 turns it off. A3. B3 turns it off. And as you can, to make sure it works the other way, we turn A off, only B1 is on. The first light comes on. Same with the second bit and the third bit, so our XOR is working. Reset everything back to 0, and now we'll do our last one, which is addition. So addition is now set. Opcode is in 0, 1, 1, 1. A and B are lined up, so let's go 1 plus 0 is 1, so 1 plus 1 becomes 2. 2 plus 1 becomes 3. 6 plus 1 becomes 7. Let's go to 2. 6 plus 2 becomes 8. 6 plus 4 becomes 6. And then we'll go all out. We'll go 7 plus 7. And we should be having 14 here. And that is 2. Plus 4 is 6. Plus 8 is 14. So as you can see, our addition works. And that is my ALU unit coded on an FPGA for the midterm.